Hi, I'm here today to give a brief description of my project which looks at the in vitro modelling of the lungs' response to environmental nanoparticulates. As a scientist, I, like others, worry about the polluted air around us, especially when it comes to children. What is normally reported in the media are combustion particles looking at the micrometer scale. However, particles in the sub-micrometer scale, nanoparticles, are in recent studies bringing to light their toxicity within the lung. Air pollution is one of the single largest environmental threats that we face and is a global epidemic costing more lives than HIV, hypertension and diabetes combined. The need to regulate air pollution is highly recognized. However, what is typically considered as particulate matter of less than 2.5 micrometers, which doesn't really focus on the nanoparticulate range of 1 to 100 nanometers. And studies have shown that toxicity can be found at levels well below the threshold set by the WHO. In addition, due to strides made for lowering carbon emissions, increasing energy efficiency, households with modern air tightness and poor ventilation accumulate nanoparticles, potentially causing negative health effects. Over the years, various approaches have been used to investigate the toxicity of particulate matter, many cases involving animal testing. Currently, there is no accepted in vitro model which acts standalone in acute inhalation toxicology studies, replacing animal models, and this is due to the limitations shown. The aim for this project is to develop a better understanding of nanoparticle toxicology, produce predictive in vitro models, and reduce the need for animal models. To tackle this, I will identify nanoparticles within the ambient air, both indoors and outdoors, such as copper nanoparticles from brush motors like vacuum cleaners and blenders. I will then expose both alveolar and bronchial epithelial cells, cell lines highlighted below, with various nanoparticle concentrations, for which afterwards performing toxicological assays for such parameters as viability via lactose dehydrogenase assay. Then, increasing the complexity and representability of the model, I will use an air-liquid interface model and at Public Health England, exposure chamber air-liquid interface with equipment such as Caltex, exposing nanoparticles to cells and performing toxicological assays. This will be in conjunction with high-content analysis to develop an understanding of toxicological activity by converting images into morphometric data to reflect cell population response, and expression studies to develop an understanding on potential modes of action of the selected nanoparticles. Thank you for listening.